Paired data and graphing. Let's recall that when we have a pair of numbers enclosed in parentheses and separated by a comma, such as what you see here, -2, comma 1, this is called an ordered pair of numbers. The first number is called the x-coordinate and the second number is called the y-coordinate. So for this ordered pair, the x-coordinate is -2 and the y-coordinate is +1. And what we can do to represent ordered pairs is we can graph them in the coordinate plane, which you see here. The coordinate plane is simply a number line, which we draw horizontal, which is the x-axis, and another line, that we draw vertical, which is called the y-axis. This divides up the region into 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we can use this to graph these ordered pairs. So for example, the ordered pair -2, +1 corresponds to -2 on the x-axis and +1 on the y-axis. And if we line those up, we can see that that point, or that ordered pair, is right here in our graph. Now the reason we do this is because we can show relationships between the two variables, x and y. So for example, let's go ahead and plot, which just means to graph the ordered pairs 2, 5, -2, 5, -2, -5, and 2, -5. And what you should see is that all these points are kind of similar, but they correspond to different values on the x and y axes. So +2, +5 is in the first quadrant because this is where x equals +2 and where y equals +5. In the second quadrant, the x-coordinate is negative and the y-coordinate is positive, and so the point -2, +5 would be here in the second quadrant. -2, -5 is where both coordinates are negative, and that occurs in the third quadrant. X equals -2 is here, y equals -5 is here, and here is the point. And finally, 2, -5 is in the fourth quadrant. So let's just take a look at a few more ordered pairs. The ordered pair 1, -3 would be x equals 1, y equals -3, which is this point here. Now a point like 1/2, comma 2, when you go to graph x equals 1/2, you just kind of need to estimate that 1/2 would be right about here on the x-axis. So I'm going to go to that number, and then y equals 2 is up here. So you can see that's the point 1/2, 2. The point 3, 0 is x equals 3, but y equals 0, so we do not go up or down at all, just right here on the x-axis. Likewise, the point 0, -2, x equals 0 is right here, and then y equals -2 drops down. Similarly for -1, 0, and also for 0, 5. Now let's talk about graphing equations. So what does it mean to graph the equation y equals -1/3 times x? Well, what we're doing here is we're graphing all of the pairs of x's and y's that go together that satisfy this equation. So to do this, we often want to make a table. So I'll just draw a quick table here, and this table is going to represent x values and y values. And what I'm going to do is plug in numbers for x and then figure out what the corresponding y value would be. And I'm going to plug in smart numbers here, okay? So I'm going to plug in x equals 6 as my first choice. So if x is equal to 6, y is going to be -1/3 multiplied by 6. And this gives us -2. Now, why did I call that a smart choice? Well, because I know that if I need to multiply a number by -1/3, it would be really nice if something will cancel here, which will give me a whole number for the result. So another number that would be kind of nice to plug in might be x equals 3. If x equals 3, y is -1/3 times 3, which is equal to -1. Another nice number, which is almost always nice to plug in, is x equals 0. If x equals 0, y equals -1/3 times 0, which is 0. And then I can also plug in -3. In that case, y will be -1/3 times -3, which is +1. And I can plug in a few more points if I wanted to, but this is enough to graph the equation. So let's see, 6, -2 is this point here. 3, -1 is right here. 0, 0 is the origin. And -3, +1 is here. Now, there are lots of other numbers that we could have plugged in between all of these numbers. And what you would have seen if you would have plugged in numbers in between, say, 3 and 6, is you would get points in between these 2 points. So I'm going to connect these points. And of course, the graph of this equation here is a straight line. So what we're doing is we're graphing ordered pairs that satisfy this equation to show the relationship between the variables y and x if y is equal to -1/3 times x. So that last example is a special case of a general form of an equation of a line, and that is a line through the origin. Anytime you have an equation y is equal to m times x, where m is any number, this is always going to be a straight line through the origin. And so here are a couple of other examples. If we graph y equals 2x, so if you made a table and got some points, you would see that you would get this line here. Notice that it goes through the origin here. Y equals 1/2 times x would also be a line passing through the origin here. And y equals x is also a line through the origin. So in this case, m is equal to 2, here m is equal to 1/2, and here m is equal to 1, referring to the m here. Next, let's talk about intercepts. The x-intercept of a graph of an equation is the x-coordinate of a point where the graph crosses the x-axis. And the y-intercept is defined similarly. So the y-intercept is the y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So for example, if I have an equation such as 2x plus 3y is equal to 6, I can graph this equation by simply finding the x and y intercepts. So let's think about this now. If I want to find the x-intercept of a graph, the way to do this is to let y be equal to 0. Now, I'll show you why in just a minute. But if I plug y equals 0 into this equation, we're going to get 2x plus 3 times 0 is equal to 6. That says 2x equals 6, or x is equal to 3. So when y is equal to 0, x is equal to 3. That gives us the point 3, 0. To find the y-intercept of the graph, we are just going to let the other variable equal 0. If I let x equal 0, we get 2 times 0 plus 3 times y is equal to 6. This says 3y equals 6, which means y must be equal to 2. So when x is equal to 0, y is equal to 2. And now if I bring in a coordinate system here, the point 3, 0 is x equals 3, y equals 0, which is right there. And the point 0, 2 is right here. And now just using those 2 points alone, we can sketch the graph of the line. Now, why is it that to find the x-intercept, why did I let y be equal to 0? Well, think about it. Wherever the graph crosses the x-axis, that's going to correspond to y equals 0 on the y-axis, right? So anytime you want the x-intercept, you simply let y equal 0. Similarly, to find the y-intercept, we let x equal 0. This is because wherever the graph crosses the y-axis, the x-coordinate of that point is always going to be 0. Next, let's find the intercepts for a slightly more complicated equation. In this case, we have y equals x squared minus 4. So let's go ahead and find the x-intercepts. Remember, to do this, we are going to let y be equal to 0. So if I plug in y equals 0 here, we get 0 equals x squared minus 4. And then we can solve this equation for x. Now, there's a couple of different ways we can solve it. One way to do it is I can factor this, right? And then I can set each one of these factors equal to 0. And that is going to give us two numbers, x is equal to 2 and x is equal to -2, which means the x-intercepts are 2, 0, and negative 2, 0. Now, of course, another way to solve this equation here is I could have just added 4 to both sides and then taken the square root, and this would have given us x equals plus or minus 2, right? Same answers. Okay, now how about the y-intercept? Well, to get the y-intercept, this is actually a little bit easier. We're just going to let x equal 0. And if I let x equal 0 right here, that's just going to give us y equals 0 squared minus 4, which is negative 4. And so the y-intercept is 0, negative 4. Now let's take a look at that graph. So here is a coordinate system. We have the point 2, 0, which is right here, the point negative 2, 0 right there. So those are our x-intercepts. And then 0, negative 4 is right here. Now, we'll learn a little bit more about these graphs later on, but this is the graph of a parabola, and it goes something like this. So the reason why we like intercepts is because intercepts are generally pretty easy to find, and just by graphing a few points, you can get a really good idea of what some graphs look like. Same thing here for this problem. Let's sketch the graph of y equals x cubed minus 4x using intercepts and a table. So in this case, we're going to use intercepts and maybe a few additional points. So let's see. To find the x-intercepts, we're going to go ahead and let y be equal to 0. So if I put in 0 for y, we get 0 equals x cubed minus 4x. To solve this equation, I'm going to factor out an x. And then I'm going to factor out a little bit more here, just like we did in the previous example. And now I'm going to set all 3 of those factors equal to 0. And in this case, we are going to get 3 answers. X equals 0, 2, and negative 2. And so our x-intercepts are the points 0, 0, 2, 0, and negative 2, 0. Now, to find the y-intercepts, we are just going to let x be equal to 0. If I let x equal 0 here and here, we're going to get y equals 0 cubed minus 4 times 0, and this, of course, is 0. So when x equals 0, y equals 0. Well, yeah, we already knew that point, right? So anytime you get the point 0, 0, that is both an x-intercept and a y-intercept. So now for the graph, let's go ahead and graph these points. We have the point 0, 0, we have the point 2, 0, and we have the point negative 2, 0. Now, I'm not really confident about what this looks like, right? We can have lots of different kinds of graphs that go through these 3 points. So in this case, we might need to get a few additional points. So if y is equal to x cubed minus 4x, let me go ahead and plug in a few additional x values. Let me plug in x equals 1, right? That's this number right here. Let's plug in x equals negative 1. And then let's plug in x equals 3 and also negative 3. And let's see what we get. So if x equals 1, y is going to be 1 cubed minus 4 times 1. This is 1 minus 4, which is negative 3. If x equals negative 1, we get negative 1 quantity cubed minus 4 times negative 1. This is negative 1 plus 4, which is positive 3. If we plug in 3, we're going to get y equals 3 cubed minus 4 times 3. This is 27 minus 12, which is 15. And finally, if I plug in negative 3, we get negative 3 cubed minus 4 times negative 3, which is going to be negative 27 plus 12, which is negative 15. Okay, so we have a few additional points here. We have the point x equals 1, y equals negative 3. It's right here. X equals negative 1, y equals positive 3. And then we have the point 315. Now, 315, look at the y-axis here. Y-axis only goes up to 6, so 315 is way up here somewhere. I'm just going to put a point up here really high. And negative 3, negative 15 likewise is a point down here very low. So what's happening here with this graph is we have a function that is coming up like this, turning around, right? Going through the intercepts and going back up. So again, just by graphing the intercepts and a couple of additional points, we can get a fairly accurate picture of that graph. Now for a couple of special examples. These are special lines. So the line x equals 3, the reason it's special is because if you think about making a table to graph that line, the x value must be 3, right? That's what it says. X is equal to 3. So that means x always has to be 3. Y can be whatever you want it to be. So if you graph those points, 3, 4, 3, -1, 3, 0, 3, 3, you can see that you are getting a vertical line through the number 3 on the x-axis. So this is always going to be a vertical line. Likewise, if I want to graph y equals -2, I can do that just by making another table. And what we know now is y is always going to be -2, and you can pick any number you want for x. So if I graph these points, 3, -2 is right here, 0, -2, 4, -2, -1, -2, you can see that we are getting a horizontal line. And so, in general, anytime you have x is equal to a number, it's going to be a vertical line. Anytime you have y equals a number, it will be a horizontal line. So now just a few facts from geometry. These are special equations and their graphs. So it's kind of a summary of what we talked about. So anytime you have an equation y equals m times x, this is always going to be a line through the origin, but it's a slanted line. If I have an equation x is equal to a, that's always going to be a vertical line that goes through a on the x-axis. If I have y equals b, that will be a horizontal line hitting b on the y-axis. And now for an application. In May 2005, the city of Lyon, France, started a bicycle rental program. Over 3,000 bicycles are available at 350 computerized stations around the city. Subscribers pay an annual €15 fee, which is about $19 at least at that time, and get a PIN to access the bicycles. The bicycles rent for €3 per hour and can be returned to any station. So your community decides to set up a similar program charging $15 subscription and $5 per hour for rental. Any fraction of an hour is charged as the corresponding fraction of $5. So make a table of the values showing the cost C of renting the bike for various lengths. So let's think about this. In our community, we are charging a $15 subscription fee and $5 an hour. So think about this for a minute. If somebody rents a bike for 3 hours, the cost is going to be, first of all, you have to pay that $15 subscription fee, and then you're going to pay $5 multiplied by the number of hours. So that's going to be $5 multiplied by 3 hours. This would be $15 plus $15, which is $30. Right? If we rented the bikes for 7 hours, let's say, the cost is going to be $15 subscription fee plus $5 multiplied by 7. And this is going to be 15 plus 35, which would be $50. Okay? So let's go ahead and think about what if you rented the bike for 0 hours. Sorry, just had a thought here. Then the cost would just be $15, right? Because you're still paying that subscription fee to be a part of this community, right? Because there's no hour charge here. So we can see that if we make a table and we want to do C in terms of T, so we have T hours and we have C for the cost. 0 hours cost us $15. 3 hours cost us $30. And 7 hours cost us $50. Now we're going to plot the points on a graph. Okay, so for this, I'm just going to draw my own coordinate system here. And notice that I have the t-axis down here and the c-axis up here, and I'm not showing any negative values because negative numbers don't make sense for this particular example. So now let's go ahead and scale our axes here. So the x-axis will do 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the c-axis, you can see the values I have on my table go up to 50. So I need to make sure I go at least that high. So let's say we go 10, 20, 30, 40, and 50. All right, now we can see that when we rent the bike for 0 hours, we're going to pay $15. That's right about there. 3 hours, which is right here, costs us $30, which is right there. So that's going to be this point. And 7 hours, which is right there, costs $50, which is right about here. And so the graph of this line is going to look something like this. Now notice that I don't have the graph over here because this over here doesn't make any sense, right? We're not going to rent the bike for a negative number of hours. So the graph actually stops right here. And then the last thing we want to do is write an equation for C in terms of T. So if we come back to these examples here, you'll notice that the cost was always $15 plus $5 multiplied by the number of hours. And if you're renting it for T hours, it would just be 5 times T. So we can say C is going to be 15 plus 5 times T. And this would be the equation that represents this particular situation. And that concludes this video lesson.